to session 5 of unit 4. This session will introduce you to nuclear reactions going on in our bodies. By the end of this session, you should understand the nuclear reactions going on in the human body. There are nuclear reactions that are going on in the human body, and they are very few as compared to chemical reactions. So because of that, they don't really have any effect on the human system. Most of these reactions that occur in the human body are chemical reactions, which means that they involve the transfer of electrons instead of involving the nucleus. For example, blood capturing oxygen and sugar being burnt or DNA being constructed are all examples of chemical reactions that occur in the human body. In radioactive decays, high energy radiations are produced, and when these reactions occur in the human body, they could damage the human body. But fortunately, the human body has mechanisms that eliminate this kind of radiations from the body before they can be so high that they would even have an effect on the human body. So in a nutshell, what the message I'm trying to put across is that these nuclear reactions do occur in our body, but the body is able to eliminate their effects, and they are not as much as the chemical reactions that occur in the human body. Let us look at some of the common causes of human exposure to high radioactivity. So one of the major causes is the exposure to naturally occurring radon in the ground. So all the forms of isotopes of radon are radioactive, and when humans get exposed to them, the radons also decay into other radioactive isotopes which are very dangerous to human health. We discussed radons in our previous slides. Another common cause of exposure is as a result of employees working in nuclear reactors or nuclear weapon facilities. These people are prone to these radioactive materials. In order to prevent this exposure, strict policies and personal radiation gauges helps to prevent this exposure. Also, when people come too close to nuclear weapons when they are being tested, it leaves them exposed to this kind of radioactive materials. It is very important to note that when you have a single medical scan performed that requires drinking or being injected with a radioactive tracer, you do indeed end up with more nuclear reactions in your body than normal, but the level is still low enough not to be dangerous, and therefore is not included on this list. In our previous slide, we mentioned that when someone is exposed to radioactive materials medically, the radioactive materials are introduced to the system in a very minimal amount that they do not have any significant effect on the person. The most common natural radioactive isotope in humans is the carbon-14 and potassium-40. So chemically, these isotopes behave like stable carbons and potassium. When you have the carbon-14 in your system, the carbon-14 atom will decay to a stable nitrogen atom, and potassium-40 atoms will also decay into calcium atom, and all these nitrogen and calcium are very important elements that the body needs, and so they will have no negative effect on the human. So the occurrence of this carbon-14 decay in the human body is the principle behind carbon-14 dating. So as long as this individual lives and the person is still eating, every carbon-14 that will decay into a nitrogen will be replaced by another carbon-14. But once the person dies, this replacement of carbon-14 will stop. slowly these carbon-14s will all decay to nitrogen, and there will be no more carbon-14 to replace them, because the person is dead and the person is no more consuming carbon-14. Now the rate at which carbon-14 decays is constant and well known. So if we measure the relative amount of carbon-14 in the bones, then we can calculate when the person died. And this is basically what the archaeologists use. This is a self-assessment question that I want you to have a look at.